Hello again, everyone. So I hope you are all guys having a good day. So let's proceed to the next topic for the application of differential equation. So today we have the Newton's second law of motion, which is also known the limiting speed. So take note that this Newton's second law of motion is not the same. It's not the same with the Newton's second law of motion in physics. So this is a different theory or a different topic. Okay, so let's go with the uh, definition. So for the definition of Newton's second law of motion or the limiting speed, it simply implies that a free falling body released from rest will achieve a limiting speed after a certain time. So this really simple. So what happens here is if a body, let's say a ball, so a ball is released from rest, uh, and now it is a free falling body, right? Now, while it is a free falling body, while it is falling and traveling through the air, after a certain time, as you all know, the acceleration of the ball at during that time is, let's say that's the acceleration due to gravity. That's 9.81 meter per second squared. So let's say after 1 second it will become 9.81. After 2 seconds it will become twice the 9.81. After 3 seconds, and so on and so forth. So as you can see, it will have an increase in its speed over time. However, Newton said that the ball will not achieve an infinity speed. It will achieve a maximum. It will achieve its maximum speed, and after that, it will no longer change the speed or the velocity of that ball of that body. So let's say after 10 seconds, after 10 seconds, it will achieve, let's say, 160 meter per second, and that will be that will be the limiting speed of the ball. Okay, so after 20 seconds, it will still become 160 meter per second. After 30 seconds, still 160. So that's what it meant by limiting speed. And another definition that the air resistance is directly proportional to the velocity. Okay, so I already have here the symbols that we will be using. So we have R for air resistance, V for velocity, Vm for limiting speed, weight, mass, acceleration A, proportionality constant is K, and of course, acceleration due to gravity is G, and we have the T for the time. Okay, so let's start. So I will start here by drawing the figure first. Figure, or we can also call this a free body diagram. Hmm. So we have a figure here. Nope. Let's say that there's a free falling body. Best example is, I think, is the ball. So we have the ball, a really simple ball. And then, of course, this will be your ball. It's your ball. Now, if there's a free falling body, what are the forces involved for this one? Of course, we will have here going down. Oops. Um, Going down, we have the force of the weight, which is the weight of the ball. Therefore, you'll have here your W, right? And then remember that unlike in physics, we always neglect the air resistance. But here we have to consider the air resistance. Of course, while the ball is going down, the air resistance is from the word itself, it resists. Therefore, if the ball is going down, it opposes your motion, or it opposes the motion of the ball. Therefore, if the ball is going down, the air resistance must be going up. So you must have here an air resistance. The symbol for air resistance that we will be using is R. So you must have here R. Okay. So this will be your weight, and this will be your weight, and this will be your air resistance. Okay. So let's construct the forces along this the summation of forces. So as you can see, the ball is traveling down or going downwards. Okay, so the motion of this ball is going down. Therefore, as you can see, if we will make this a Cartesian diagram, Cartesian plane, this will be your negative side, right? That will be the negative side of y, and this will be your positive side of y. Therefore, that is going down. Therefore, your motion must be negative m. Your motion is ma, right? Summation of forces, if the body is moving, it must be equal to ma. Now, what are the forces? So we have summation of forces. Okay, summation of forces along y must be equal to ma, right? And what are the forces along y? We have positive r, and then positive r, and then w, or the weight, must be negative, so negative w. And this must be negative, right? Because it's going down. It's going to the negative. So this must be negative m. Now, if you kind of got confused here, as you can see, if we will make a Cartesian plane here, of course, this is your x, this is your y, right? This is your positive side of y, this is your negative side of y, positive side of x, negative side of x. That's why your r must be here and your w is here. And then since it's going down, the ma must be also negative because it's going to the negative side. I hope that is clear. So I'll just erase this one. Now remember, from the second definition of air resistance is directly proportional to the velocity. So we can say that the air resistance, oops, we can say that air resistance is directly proportional to what? To the velocity. So v. Now applying the concept of proportionality, we will have here r must be equal to, we must add here a proportionality constant, which is the k. So I will be using k. So r must be equal to kv. And of course, we also know that the weight is also to equal to what? Weight must be equal to mg. Okay, now let's substitute this one and then this one to here. Okay, okay, substituting. So substituting will have here r minus w must be equal to negative ma, and then r is kv, right? And then w is equal to mg minus I equal to negative ma. So since this is a topic in differential equation, so I must have something here, something like dx over dt, dy over dt, dy over dx, or something like that. So what I will do now is divide everything or multiply everything by 1 over m. Let's make it negative m. No, I can just have m. Okay, m. So you'll have here kv over m, and then negative m will be cancelled. You'll have here g, and must be equal to mm, negative a. Yes, okay. And then next, I will transpose a or negative a to the other side, and then g to the other side. So I will have a positive, everything is positive now. So a now will become plus kv over m equal to g. Okay. So a plus kv over m must be equal to g. But remember, during your differential calculus, a, or the acceleration, is also equal to a is equal to what? This is the change of velocity with respect to time, okay, or velocity over time. So we can also say that this is dv over dt. Okay, so I hope you all remember this one. So that is just a recall in differential calculus. Okay, so going with this one, you'll have here, let's substitute the value of a, or the dv over dt. Replacing a, you'll have here dv over dt. The derivation of a formula of for this one is quite long, so bear with me. Plus, as you can see now that dv, therefore your v will be our variable. I will just isolate v also here. So this will become k over m v equal to g. Okay, then next, as you can see that this differential equation is what type of differential equation this. This is a FOLDE, or first order linear differential equation. So I hope you still remember the solution for this one. So as you can see, this is linear in V. So if that is linear in V, we can get now the IF, or the integrating factor. Okay, so solving for the given first order linear V. Whoops. Okay, now we can have here. So solving for that, we have to get the IF first, or the integrating factor. So for the integrating factor, okay, this is equal to e raised to whatever this is. Okay, so that's k over m, integral of k, okay, over m, and then dt. Applying the integral now, you'll have here e raised to k over m t. So this will be your integrating factor. Now, having the solution, since this is linear in V, therefore you'll have here V, the integrating factor, which is e k over m t, equal to the integral of whatever is this here, that's g. So we have here g e raised to k over m t, d t, don't forget the plus c, of course. So now you'll have your v e raised to k over t equal to integral of this one. You have to reciprocal m over k. Therefore, you'll have your g m over k, right? E raised to k over m t plus c. Okay, but of course we have to get rid of the c. We have to find the value of c. But as you know, if we will have a condition here, as implies here, that simply implies that a free falling body released from rest. Therefore, we can say that the first condition is, so at t must be equal to 0, v must be equal to 0 also. Okay, considering t equal to 0 and v equals to 0, let's substitute these values to the equation. So you'll have here v is 0, right? Therefore, you'll have your 0 e raised to k over m, and this is also 0. This is equal to g m over k e raised to k over m times 0 plus c. Okay, so let's cancel some of the equation. So this will become 0, right? Because that is multiplied by 0. So everything will be 0. And this one, that is e raised to k over m times 0. So everything that is, anything that is raised to 0 is equal to 1 except 0. So this is equal to 1. Therefore, we will be left with, this is 0 equal to gm over k plus c. Therefore, we can have that c is equal to transpose gm over k negative gm over k. Okay, so I will be erasing this part. Okay, so erasing that part, you'll have okay. Now we have to substitute this one to this equation. So we'll have here v e raised to k over m t equal to g m over k e raised to k over m t again. But c is equal to this one. So this must be minus g m over k. So let's try to factor out. We can factor out gm over k on the right side. So factoring that out, you have v e k over mt must be equal to. So factoring that out, okay, this is equal to. Sorry, e raised to k over mt minus 1. There you go. So I think it's better if we multiply or divide everything by e over k over uh, e raised to k over mt first. Okay, so let's do that before factoring out. Okay, so divide everything by 1 over e raised to k over mt. Okay, and then next, so dividing everything, we will left here with just v, right, equal to this is just g m over k, and this will become negative gm over k. Then you must have here over e raised to km over t. But what will I do is I will bring it up, so the exponent must be the exponent of the e raised to k over mt will be negative. So e raised to, it must be negative now because I brought it up, mt. I think this is simpler. Now let's factoring out gm over k. This is a 1 minus e raised to negative k over mt. Okay. Okay. Now, for the next step, I'll be erasing this one again, this part. There we go. Okay. So for the next step, remember that we have to consider the limiting speed. So the symbol for that I will be using is Vm, capital V, small m. And then if I want to get the limiting speed, so take note again, if your speed after 10 seconds, let's say, is 160. After 20 seconds, that is still 160. After 30 seconds, that is still 160. Therefore, the limiting speed is 160. Therefore, to get the limiting speed, the limiting speed is still the same even the time approaches infinity, or even the time, it doesn't matter what the time is. The limiting speed is still the same whatever the time is. Therefore, I can consider here that during limiting speed, t must approach infinity. Okay, so when the velocity is the limiting speed, okay, so velocity, so v must become the limiting speed, or vm. T must approach infinity. Okay, now considering these conditions, you'll have here, so v, I will change v now to vm. Okay, vm must be equal to Gm over k 1 minus e raised to negative k over m. This is infinity. Okay, infinity. Okay. So remember that this part, I'll be separating this part only. Okay. Okay. So separating that part, remember that that e is raised to negative k over m raised to infinity. I can also write this by e raised to k over m infinity, right? So it will become now positive. So as you can see, a 1 over a very e raised to k over m, again, e raised to k over m times infinity is a very large number, right? Because e raised to infinity is a very large number. So you can also say that this part is 1 over e raised to infinity. So 1 over a very large number, as you can see, that is just equal to, also equal to, approaching 0. That is approaching 0. Now, if you doubt that, what happens here is, let's say that this is 1 half is equal to zero point 0.5, right? And then 1/3 is equal to 0.33. And then 1/4 is equal to 0.25. Ah, right, 0.25. And 1/5 is equal to zero point 0.2. As you can see, uh, as the denominator gets larger, the value of the fraction gets smaller. Therefore, if I will make the denominator a very large number, it will soon approach to 0. That's why I can say that this one, 1 over a very large number, is also equal to 0. Okay, so I hope this one is clear. Therefore, if this factor is also equal to 0, therefore I can say that this part is also equal to 0. Therefore, we are left with the limiting speed is just equal to g m over k. So that will be your limiting speed. Now going back to this one, to this one, as you can see, gm over k is equal to vm, or the limiting speed. This is also gm over k. That means this part is your limiting speed. Therefore, constructing the final formula, we can have v must be equal to the gm over k is just the limiting speed, okay, times 1 minus e raised to negative k over m. I think we are not done yet. K over t. Okay, so we still don't have any value for k and m, so we have to eliminate that. So to eliminate that from this equation, to get k over m, what I will do is I have to multiply k here, cross multiply k to vm, and then m must go down. So you'll have here, from this equation, you'll have here k over m must be equal to g, and then vm must go down over vm. Therefore, the k over m can be replaced by g over vm. Therefore, I think the final formula, the very final formula, will be v is equal to the limiting speed vm multiplied by 1 minus e raised to negative g t over vm. Okay. So this will be the formula for the differential equation, application of differential equation, Newton's second law of motion, also known as the limiting speed. So remember that Vm is your limiting speed and G is your acceleration due to gravity. The value for that is 9.81 meter per second squared, or 32.2 feet per second squared, and your times the time all over the limiting speed. So with that, let's proceed to some sample problems so that I can show you how to use this formula. Okay, so let's go to our first problem, which is a body falls from rest. So if the resistance of the air is proportional to the speed and the limiting speed is 160 feet per second, and find the speed at the end of 5 seconds. So let's put all the givens first. So for the given, we have, let's make this smaller. The given, we have limiting speed. So Vm must be equal to 160 feet per second. And then we also have the time for 5 seconds. I think that's it. Okay, so if we will be using 160 feet per second, remember that G must be equal to 32.2 feet per second squared. Oh no, here you go. Per second squared, okay? Now, remember the formula that we'll be using is V must be equal to Vm 1 minus E raised to negative GT over Vm. That's it. So this is just a direct substitution. So analyzing the problem, as you can see, the limiting speed or the maximum speed that the body can achieve is only 160. So therefore, the answer that we must get here, it must be less than 160. So we are asked to find the speed of the body at t at the time or after 5 seconds. So v must be equal to Vm is 160 times 1 minus e raised to negative 32.2 times t is 5 and then all over 160. So let's try this in calcu. So trying this out. Calcu, that's 160 times 1 minus negative 32.2 times 5 all over 160. So the answer is 101.560. This must be feet per second. Yes. So as you can see, this is just direct sub if you already know the formula. So I think that's it for this video, and I hope I was able to help you again during these online classes. So if you haven't already, don't forget to subscribe to my YouTube channel and of course hit the bell notification icon so that you will be notified as soon as I upload a new one. So I want to thank you all guys for watching and have a great one, and I'll see you on the next one. Bye bye.